So good morning, you guys. Let's bring up our title for the day so we know what we're doing. I'll go ahead and pause here, and you guys can write at the top of that handout that I gave you what our objective is. Today, as promised, we're going to talk about how you can tell which strategy to use and when. And so to kind of begin that discussion, I've given us a sheet here. The issue is the rational expressions. If you guys don't know what a rational expression is, it's anytime you have basically a fraction with letters in it, okay? So the issue is we've learned a lot of different integrals with fractions and letters in them, and they all have different strategies. And the question is, how do you know when to use each strategy? Well, let's go ahead and start with something easy, okay? Up here at the top, let's look at this first one here. We're looking at ones that are of the form y equals 1 over x to the n. So in other words, there's a number on top and just one letter on the bottom with a power on it, okay? Well, really, there's only two kinds. There's only two kinds there. Either A, they have a power of 1. So for instance, you'll want to fill this in with me. 1 over x, that's to the power of 1, right? Or, can we keep this? Huh? That's for you, yeah. So, or the power will be something else than 1. So for instance, y equals 1 over x squared. So those are the two types. It could be y equals 1 over x squared or x cubed, but regardless, so long as that power is anything except 1, it goes in the second category. And here's how it works. When it's 1 over x to the first power, that's a natural logarithm. Okay? So for instance, if I were to integrate this, I would get ln of x. Okay? That's a natural log. But if it's anything else, we would bring it to the top as a negative, right? And we would do the reverse power rule, where you add 1 to the power and divide by that number. So what would this come out to be? -1, x to the -1, right? So there are two types. The first type is if you have a power of 1, that turns out to be a log when you integrate it. The other type is any other power is the one where you have to move it to the top, change the sign, and do the reverse power rule. Okay? So here's what I want you guys to do. On the handout that I gave you, I want you to flip it over, and I want you guys to integrate numbers 1 and 2. I want you to find the integrals for numbers 1 and 2 on your worksheet. Go ahead. Let's see what you guys got here so far. So here it is. As I'm coming around and looking, what I'm seeing is that you guys got the point of today's lesson. You recognize which one was which. But what I'm also seeing is we're rusty on our integration. All right. So let's go ahead and see what we can. We're rusty on old integration, right? So here we go. Pearl, the first one, is that an ln or a reverse power rule? And how do you know that's an ln?
I just was given a nice go.
Great, and how do we know that's an ln? That's right, the power of the x on the bottom is 1. Oh, no. I don't think we can talk for the rest of the day. All right, so the first thing we want to do is take out the -20, right? And then what's the integral of 1 over x? Don't forget your absolute value bars. All right. let's do another one. Shall ask Jonathan, how do we know this is not an ln, but instead it's a reverse power rule? That's right. Since the power on my x is 3, it's that. So now since it's a 3, we're going to do the process for the reverse power rule. So Angelina, what's the first thing we do if I want to use the reverse power rule? Good. That's not actually an integral, right? That's just rewriting it. Savannah, what's next? Okay, sure. We could do that. That's still not an integral, but we can do that. That's fine. Nothing wrong with that. Julia, what do we do next? We're going to do something that power. What do we do to it? Yeah, good. So if I add 1, now this actually is the integral. So now I'm going to drop the s, right? And we're going to add 1. What do I get if I add 1 to that? -2. But we need to do one more thing. What else do we need to do? We divide by -2, right? So we're going to put this over -2, right? And so here, -2 and -6 can be combined to make what? 3. So now I've got 3x to the -2. And what might be a nice way to write that answer, Chris? I know you put plus. Oh yeah, thank you. But this guy in particular, I don't like negative exponents. Oh, you can put the x. That's right. And when I put it on the bottom, it's going to become a positive, right? So there we go. That's probably how it'll look on a multiple choice option. So there it is. So when you have 1 over x to a power, if that power is 1, it's an ln. If it's not, then it's a reverse power rule. Okay? Now, why does that matter? Well, if you guys ever tried it, and I think some of you guys have, if you tried to do this, you'd run into a problem if you try to do the power rule. You don't write this, but just watch with me. If I try to do the power rule on this, move it up to the top, make it negative, if I add 1 to that, what do I get? You get 0. And then you'd have to divide by 0, and that's not allowed. Okay? So the power rule just doesn't work if the power is 1. It has to be something that turns out that it's the ln problem. All right? So there's that. Now for the rest of our worksheet. We've looked at so many problems, you guys, that, we've seen stuff that looks like this. We've seen stuff that looks like this. We've just seen a lot of things. And they all look kind of the same. They're basically just fractions with letters in them. And we need to know how to do this. I know just by looking, because I know how to tell. Right there, you've got some sort of an arc trig function. Right here, you've got a splitting the numerator. And right here, you've got a completing the square problem. Okay, so I need you guys to be able to look at them and know as well. And that's what the reverse side of your sheet is for. So let's go ahead and take a look at that. So where is it? Here it is. Now I'm going to read this to you. I'm not going to do it for you. I'm just going to read these to you and we can discuss and you guys can ask questions. But your job is going to be to take all these problems on the other side of your sheet here, and I want you to write them in the appropriate blanks. You got to figure out what kind of integration problem they are. So let's walk through it first, though. So first of all, if the power in the denominator is 1 more than the numerator. So for instance, suppose you had something like this, 3x over 4x squared minus 1. If the power in the denominator is 1 more than the power in the numerator, then that's going to be a u substitution problem where you make the u equal to the bottom. And pretty much what's going to happen is that's going to turn into an ln problem. You might want to just put that there. It's going to be an ln at that point. In this case, u is the denominator, and you end up with an ln problem as a result. Okay? So add those two things. U is the denominator, and you get an ln. Okay? Let's go ahead and take a look at the next one here. Arc trig functions. Well, they always have a binomial in the bottom. Something squared and a number that's a perfect square. And they're both perfect square roots. So like, for instance, if you had this, 2 over x squared minus 1. Well, I've got a binomial down there, and both x squared and 1 are perfect square roots, right? So that's an arc trig of some kind. After you know it's an arc trig, then you got to start making decisions. Is this arc sine, arc tangent, arc secant? What is it? But that's it. Now, if you have a variable in the numerator, it could be a u sub with an arc trig. So for instance, suppose I had this 6x over I wonder if that would work. Let me think for a second. I think it would. 4x squared plus 4x to the 4th plus 9. So if you had that, so notice that notice I've got perfect squares in the bottom, right? I know it's not the one right above it. Remember when we talked about before, the power in the top and the bottom, they can only be different by 1. This is a power of 4, this is a power of 1. So this is not a u sub that gives me an ln, right? So that rules out the u sub issue at the top. But I do have perfect squares, right? So that's a ding ding for arc trig functions, right? The issue here though is that it's a 4. So we talked about those though. What you do is you rewrite them as squares, and you do a u sub. Okay, so if you have a binomial in the denominator, both terms are perfect squares, it's probably an arc trig. And if there's a variable in the top, it may be the one where you have to rewrite it as a square and do a u sub before you can do the arc trig. Okay, so that's another thing that we've looked at. Let's take a look at another one. Completing the square is really easy to identify. Okay, if you have like a trinomial on the bottom, that's going to be a completing the square problem. Yeah.
You write these all on the right side.
You know, you don't have to write these. You can wherever you want if you want to. But what I do want you guys to do is you're going to take the problems on the other side and fill them in these blanks here in a minute. So for now, I'm just teaching you. But if you want to write these down as extra examples, you can. Sorry, I wasn't very clear about that. Long division. Okay, now the last two are a little bit tricky. Let's take a look at long division. Polynomial in the numerator that has a higher power than the denominator. So for instance, if I had this x squared plus 1 over, well, 2x plus 1 over x minus 3, you could do long division with that because the power in the top is greater than the power in the bottom. It would work. Now, I realized before I wrote that, though, I was going to write this. Now, you could do long division with that, right? It would work. But you know it'd be a heck of a lot easier? Just rewriting it. Because this just becomes x, this becomes 2, and there's your 1 over x. And that's actually the exact answer you would get by doing long division. So, here's the unfortunate thing. There's really not a great way to tell when to do this one. Keep it in the back of your mind. If nothing else seems to be working well, it's kind of like your last-ditch effort, if you will. Matter of fact, I don't even like what I put here because I don't think that's true. So let's cross that off. Let's just say it's something we want to remember and consider as a possibility. There's really no good way to tell as far as I can tell. I mean, I know, here's how I know when you want to split the numerator up. I can tell just by looking. Like last night, you guys had a homework problem that looks like this, right? Remember that one? Well, to me, I just thought, gosh, if I split this up, this becomes 1. And that's really easy to integrate. Right? So my best answer is, how can you tell when to split a numerator? The answer is, well, just kind of look at it and see, will that simplify things if I do that? If it does, then go for it. Yeah.
Why does 1 over e become e?
To the negative 1.
Yeah.
All right, so there you guys go. That's kind of the story and the summary of it all. That's all the strategies we've learned. Now, what I'd like you guys to do is take a couple of minutes and sort these out. I think I have 3 arc-trig functions in here. So in that one that says arc-trigs, you're going to have 3 problems in that one row alone. But anyway, go ahead and sort out numbers 3 through 9 and see if you guys can get them in the right spot. So I'll give you a couple minutes for that. So let's ask John V. What problem did you put here? Good. Okay. So it fits the rule, right? We have a power of 4, right? And that's 1 more than the top. So I think you did a good job of identifying that. But that's not the right answer. Now let me tell you why. You ready? This is frustrating. The derivative of the bottom needs to be in the numerator. So if I take the derivative of the bottom, what do I get? 4x cubed. Now, that 4x cubed is not going to cancel all the x's on the top, will it? That won't cancel. And so that's why the u sub method won't work. So it has to satisfy both criteria. So actually that is not what goes there. But you did apply the rule I gave you pretty well. Let's go ahead and see if, Vivian, what did you put there? You put the same thing? Okay. That's all right. You applied the rule well. Neha, what did you put here? Is that right? Did I write it right? Oh, 4th? Okay, so once again, we have the power in the bottom being 1 more than the power in the top, but this time, what's the derivative of the bottom? 25x to the 4th. Will that get rid of all the x's on the top? Yes, that's your u sub problem. And another thing that I just realized is, I had you guys write over here ln. Would you guys cross that off? A lot of the times it will be, but this one actually, it doesn't have to turn out to be an ln problem. So I was wrong about that, because this one would not be an ln problem. But it is the case that your u will be in the bottom. So that is what goes there. All right, let's go ahead and take a look at the next one. Chloe, what did you get for one of your arc trigs? One of them's tricky, the other two are a little less tricky. What was one of your arc trigs that you noticed?
The time.
Integral?
Yeah, integral.
Uh-huh.
Integral. 1 over x squared of x squared minus 1. No. Yeah.
Like that?
Yeah.
That's right. And that would be an arc secant, right? That would be an arc secant. Thea, what was another arc trig?
4x over 1 minus the square root of 1 square root of 1 minus 4x over 4.
She's right. That would be one where you have to rewrite it as a square and do u substitution. But she's right. All right, let's take a look at another one. Zarina. There's one more, and it's hard to recognize. Do you know what it is? It is. Nick, what's on the bottom? Okay, so this one's offensive. This one's like, really? Okay. Are these perfect square roots on the bottom? No, but we talked about this too. You can make it a perfect square by taking out 9/5, and you end up with 1 plus x squared. So those are perfect squares, and that would actually be an arctangent problem is what that one would be. All right, so let's continue. It was the integral of -9 over 5 plus 5x squared. Now I don't imagine that you guys missed the this next one, but maybe you did. It's okay if you did. Can I erase? Huh? Okay. Let's go ahead and take a look at completing the square here. Trinomial in the denominator. I'm going to ask Nick.
I got integral of 4 over x squared minus 8x plus 7.
Yeah. So that's one where you'd have to complete the square. All right. Next, Tristan. What's the long division one?
X squared plus 4 minus 7 over x squared.
Good. That would be a long division problem. Now there's only one left, right? What would the last one be? So, Andrew, what's the last one here going to be?
It's going to be 2x to the power of 3 plus 4x over x to the power of 4 plus 4.
Good. Now the stinky thing is this has got a perfect squares in the bottom as a binomial, right? So I imagine a few of you guys probably thought this was an arc trig. The problem is with arc trigs, they're not going to have more than just one number in the top. They won't have two like that. Okay. Actually, it turns out I'm lying. This is an arc trig, but it is after you split the numerator. Once you split it, one of those splits will be an arc trig. The other one would be an LN. That's kind of like one of the examples I gave you. Here's what I would advise you guys to do. We don't have time to actually solve every one of these problems. So what I'm going to do is I'm going to tell you guys where you can go in your notes to kind of review how to do all these. For the first one here, you know, you would probably want to look at, you might want to write this on the side there, 2.4. Arc trigs were 2.7 and 2.8. Completing the square was 2. I think that was 2.9. Long division was yesterday, and so was splitting the numerator. So 2.9 for completing the square. The last two are 2.11.
No, but the first two.
The first two? This one was 2.4 and this was 2.78. So there you guys have it. We have one more thing I want to throw at you guys. Something I've been kind of putting off because we just haven't had a lot of time to get to it, but now we do. Go ahead and write down example 2. This is just notice the title here. I would encourage you guys to write it. It's called extra variables, which is different than having extra constants left over. The reason for that is because what do we do when we have a constant? We just pull it out, right? It doesn't get affected by the integral. That is not true with variables, because when you're integrating with respect to a variable, if that variable is affected by the integral, so you cannot just pull the variable out like that. Okay, so let's go ahead and solve this. What do you guys think this is here? Like, what would I do? What's the strategy I would apply? It's a u sub. So let's do a u sub. And so this is going to give me integral of u to the 5th, 2x du over 3. Okay, so the 2 and the 3, those are constants, right? I could just pull those out to the front. But the problem is we have this extra x in there, and we can't have that in there. They all need to be used. So what do we do with the extra x? What do we do with the x if it doesn't cancel out? That's the question. So I'll pause here while some of you guys are catching up on your writing. So here's our answer. You guys ready? We're going to take this thing and we're going to solve for x. We're going to get the x by itself. Ready? So u is equal to 3x minus 5. So what would I do to get x by itself? That's right. Add 5. And divide by 3. Okay, so why would I do that? Well, check it out. I'm going to replace x now with what? U over 3 plus u over 3 plus 5/3. Now do I have only u's? Okay, so that's the strategy. Huh?
That's a long strategy.
Yeah, it is. It is. So, but that's how you handle the extra x's. You go back to that u, you solve for u, and then you can replace, or solve for x, and then you can replace the x. After that, we just get to do stuff. So, I'll ask once, and then if it doesn't get it right, I'll tell you what to do. Does anybody know what to do? No? Okay. There it is. We're going to distribute. Okay? This isn't obvious. We haven't done this before with integrals, but we are going to distribute that in. You'll see why in a second. So if I distribute, what's the first one become? What's u to the 5th over 1 times u over 3? plus, how about the next one? 5u to the 5th over 3, right? Just distribute. Okay, now let's do our integral, right? So, add 1 to your power, right? And divide by that number. You guys see how I just put it next to the 3? Okay. Plus, add 1 to your power, and divide by that number, right? Don't forget your plus c, of course. Okay, we're getting there. So, what do I do next? Multiply the denominators, sure. We could do that. Then what? Factor? Oh, you mean distribute in? Yeah, we're going to distribute it in. So, top times top, bottom times bottom. This will become 2u to the 7th over 63 plus top will be 10 u to the 6th over 54. Reduce? Yes, you can. Yes, you can. So I'm glad you noticed that. I'll do that too. I think let's do it now though. Okay, so does 2 over 63 reduce, you guys? No. How about 10 over 54? Does that reduce? What goes into both of those? Two does, right? So 2 goes into 10 5 times. 2 goes into 54 27 times. Where did I get what? Oh, I just moved this piece to the side, the u to the 7th. Okay. And what is our u value again? There's a lot going on there, okay? But I would say you guys know or have been exposed to most of this already. I think there's just a lot there, so it probably feels a little overwhelming. So what I want to make sure you guys got, though, is the answer to that question. What do you do when there's an extra x left over? You go back to the u equation and solve for x and plug that in. After that, I'm just going to pray for you and your algebra skills. So, because that's pretty much what it boils down to. Yeah.
Why is it 3x minus 5?
I thought that was our u value, right? Let's see. Yeah, remember how we said that u was 3x minus 5? So it was u to the 7th and u to the 6th. So I just replaced the u with 3x minus 5. That's part of the u sub thing.
Wait, but like you had to, but wasn't there still? Go back to it.
Maybe. There it is.
Oh.
Got it? Keep pondering. Yeah. Do another one? You want to do another one? Of course. Of course. You guys ready?
Wait, is it do one? Can we do one? No, I don't want to cheat. I'm just saying, like, when you give it to us in the homework, you added all these other things that
You
we
said the
saw.
homework doesn't match the lesson. So
No, I'm not saying that. I'm not saying
that's what you just said.
that's not what I'm saying.
I do my best to make sure they match, but it doesn't always feel that way, I think. All right. Go ahead and try this. Let's begin here. So go as far as you can with it. At least getting rid of all the U's, or all the X's, I mean. Nah, no such thing. All right, so Caitlin Smith, what's my U? Good. Which means that the derivative is 5. We have that. So let's do our U substitution here. So I'm going to ask Matthew, if I do my U substitution right now, what do I have? U to the 5th times X. Okay, so now I'm going to pull the 1/5 out, right? But we still have a problem. Michael, what's the problem here? There's an X. So, James, how do we handle that X?
You find X and use it.
Back over here and solve it, right? If we solve for X, what would we get, Walter? Okay. And what do we do with this U over 5 minus 3 over 5, you guys? Hello? Anybody? This looks like the same problem we just did. Is this right, you guys? Okay. I'm out of cards. So, what's next? Distribute. Good. So if I distribute it, what would I get? Okay. Now what do we do? Pearl. I ain't paying attention. Now what do we do? Oh, because I haddeth my headeth up my butteth. Pearl distracted me by staring in his face. What do we do now? Jimmy's carrying this thing, you guys. Helpful brother. Yeah. All right. So we have that. So it's going to be, oh, we're going to integrate, right? So no more integral sign. So this is going to become U to the over, which is 35, right? Minus 3U to the over 30. Good. This reduces, doesn't it? Let's reduce it.
U 6 over 10.
Oh no. I hear it. I hear the packing beginning. No! Faster!
Wait, what are you reducing?
How about 3 over 30?
It'll be U 6 over 10.
Don't go, kids! Don't leave me!
U to the 7 over
I'm going!
175.
What the heck is that?
175.
It's rock.
Minus
Oh my gosh, we might make it!
What's
No.
it?
No, we have to replace our U's. Don't give up on the U's. What is it? 5x plus 3?
That's it? Hey, lock that. Easy though.
That would be great. Your homework looks nothing like this, by the way.
Oh, dang.
I'm just kidding. You do. You have 2 problems like this at the very end.
Read my grade.
Angeline, I'm hurt.